Hello guys, very good evening and welcome to the BYJU'S Exam Prep, the most comprehensive app for all competitive exams. How are you guys? Let me know that sound quality, picture quality, everything is fine. And this is analog part 2. Here again we will discuss previous year questions from 2022 and then 21, 20, 19 and 18. And analog, that is common for electronics student, electrical students and instrumentation branch. Okay, let me know that sound quality, picture quality, everything is fine now. Okay guys, please join the session. Then here we will discuss some important numericals. I will give you the idea about which type of numericals we are going to solve here. And then finally complete solution, and you will get the idea about the different topics. Questions from voltage regulator. Give me 1 minute. Okay, you are from instrumentation branch. Then right guys, now I will give you the idea about which type of questions we are going to discuss here. We will cover question from diode circuit, like what rectifiers and what voltage doubler, clamper. Again, some numericals on what operational amplifier, some on voltage regulator, some on BJT, and some questions on what MOSFET. So almost we are going to cover all the topics, right? And some question on special diodes also, that is what LED and what Zener diode, right? Now try to solve this question, that is in instrumentation branch in 2019. I will solve this question. This is again a very interesting and integrated question. Here we are using the SR flip-flop, and that is the negative SR latch, right? And then here we are using one transistor, one LED is there, one operational amplifier is there, right? Or that is the question. Please take a screenshot and try to solve this question. And what is the 4 options for this question? That is the 4 options: A, B, C, D. In this session we will solve this question, that is from instrumentation branch. Then one question on what emitter. This is the common emitter configuration. Again, a very important topic. Every year one question on this topic, that is called RC coupled amplifier, and what is the mid-band voltage gain, right? So this is the most probable one. So we will solve this question. Please try to give me the answer for this question. Then third one on MOSFET, that is on MOSFET. Okay, so one question on operational amplifier, then second one BJT, and third one is what on MOSFET. Here we have to find the Thevenin's resistance or Norton's resistance at this point, at the source terminal. So that is in 2020 electronics. And after that, one question on diode, that is of 1 marks. How to find the average value of the signal. Okay, so Vishwanathan Murli, very good evening. How are you? So please share the link of this session, like the session. We will discuss all these questions in this session and more. Number of questions we will discuss. So these are the important numericals. And then one question on what current mirror circuit. Current mirror circuit by using MOSFET. Okay. So that is the question in instrumentation branch. Means this topic is also important for instrumentation branch. And similar type of question in electronics branch. देखिए 2019 instrumentation branch, then 2019 in electronics branch, again one question on current mirror circuit. And then one question from operational amplifier from instrumentation branch. That is important, right? Operational amplifier 3 kilo ohm. You can take a screenshot and give me the answer for this question. We will discuss this question. Okay, that is based on operational amplifier. So these are the important numericals, right? And we will discuss question from 20, 22, 21, 20, 2019, 2018. Previous year questions from analog and from electronics, electrical and instrumentation branch, right guys? So this is my introduction. Myself Sanjay Rathi. I am having 20 plus years of teaching experience, जो कि almost 21 year हो गए, और मुझे लगता है अब तो 22 years होने जा रहे हैं. And these are my achievements. I have qualified and selected for engineering services exam these are my ranks, and I have mentored more than 1 lakh students for these competitive exams. Then this is the GATE previous year question series for electronics, electrical and instrumentation branch, live subject wise question discussion. Already we have started, right? That is the 3rd session. Okay, then next one. So please subscribe so that you will get the notification about this session. And my dear students, remember one thing. अगर आपने लास्ट 5 साल के भी क्वेश्चन, अगर अभी जस्ट आपने प्रिपरेशन स्टार्ट की और आपके पास अगर टाइम लिमिटेड है, तो लास्ट 5 साल के भी अगर आपने क्वेश्चन अच्छे से बना लिए ना, और जो कॉमन सब्जेक्ट है इलेक्ट्रॉनिक्स, इलेक्ट्रिकल और इंस्ट्रूमेंटेशन ब्रांच में उनके, तो आपकी कमांड अच्छी खासी होने वाली है। और देखिए आप लास्ट 5 इयर्स में देखिए ऑलमोस्ट जितने भी इंपॉर्टेंट टॉपिक्स हैं सब पर क्वेश्चन आए हुए हैं। तो एक बार तो पूरी प्रैक्टिस हो जाएगी। जैसे यहां भी एक सिमेट्री ट्रिगर पर हम लोग क्वेश्चन बनाने वाले, और कुछ लोगों ने लास्ट क्लास अटेंड नहीं की है तो प्लीज अटेंड कर लीजिएगा। दैट इज एनालॉग पार्ट 1। वहां भी काफी क्वेश्चंस ऑलरेडी डिस्कस हो चुके हैं, जैसे कि वेव फॉर्म जनरेटर पर, सिमेट्री ट्रिगर पर क्वेश्चंस ऑलरेडी डिस्कस हो चुका है, ट्रांजिस्टर पर क्वेश्चन डिस्कस हो चुका है, मॉसफेट पर भी क्वेश्चन ऑलरेडी डिस्कस हो चुके हैं। देन इट इज अ पार्ट 2। नाउ दिस इज फॉर यू टेक अ स्टेप टुवर्ड्स सक्सेस इन गेट up to get up to 90% scholarship on preparation program. If you are focusing on what GATE 2024, then this is for you. Please note the date on 24th December 8 PM. कहाँ रजिस्टर करना है? On BYJU'S Exam Prep on ऑफिशियल वेबसाइट, और आप ऐप पर भी जाकर इसे रजिस्टर कर सकते हैं। तो चलिए स्टार्ट करते हैं। पहला है डायोड सर्किट, बहुत ही सिंपल सा इन 2022, राइट? वोल्टेज डबलर। अब आप लास्ट 20 इयर्स का पेपर निकालिए, आपको दिखाई देगा कितनी बार वोल्टेज डबलर पर क्वेश्चन आए हैं, वेदर इट इज इलेक्ट्रिकल, इलेक्ट्रॉनिक्स और व्हाट इंस्ट्रूमेंटेशन ब्रांच। चलिए सॉल्व करते हैं इसे। मुझे बताइएगा साउंड क्वालिटी वगैरह सब फाइन है? ओके, नो इश्यू। देन फर्स्ट क्वेश्चन इज व्हाट ऑन वोल्टेज डबलर। 1 minute. Give me 1 minute. Okay then. What is the voltage doubler? एक मिनट वेट कीजिएगा जरा, सम टेक्निकल इशू। हाँ, तो चलिए जब तक ये ऑन होता है, then what do you mean by the voltage doubler, right? In a voltage doubler we are applying what, first of all, rectifier with what, capacitor filter, right? Simply, and then at the output side, and at the input side clamper, and that output side, that circuit is called what, peak detector, positive peak detector or what, negative peak detector. Or at the input side we are connecting clamper, it may be positive clamper or it may be negative clamper. In this way we are designing the voltage doubler. चलिए अब स्टार्ट करते हैं उससे क्वेश्चन बनाना। अब सब कुछ सही है? ये है आपका सर्किट, यस। नाउ दिस इज सिंपल सर्किट। दिस वन is a positive clamper. Always remember, if that is the arrow, this is the diode, the direction of the current from this side to this side, so we can say directly it is a positive clamper. It is a 230 volt RMS value. So what is the peak value? 230 into root 2. It will become the peak value of the signal. When after passing through the clamper, what will be the output? If this is the sinusoidal signal, then positive clamper, output of the positive clamper is like this. What is the maximum value? 2 Vm, and this is 0. And what is the value of Vm? 230 root 2. Now this is a positive peak detector. This portion is what? Positive peak detector. What is the output? 2 Vm. So it will become 2 into 230 into what? Root 2. Now you can get the answer from this question. That is the 460 into what? Root 2. Right? So 460 into root 2. So this is the RMS value. First of all, convert it into peak value. Then what is the output value? 230 into 2 into root 2. 650.53. 53 volt. Right? So that is the doubler. Because we are getting the output as a 2 Vm. 2 Vm, that is the output. Now, next question. In the circuit shown below, all the components are ideal. If Vi is equal to 2 volt, the current I0 sourced by the operational amplifier. What is the current I0 here? Right, sourced by the operational amplifier. This is the 5 volt, that is the 5 volt. This is the Vi 1 kilo ohm, 1 kilo ohm, that is given. Now at this point we have to find the I0. Now what is the method? Very simple. In this question, if you want the I0 at this point, first of all find the voltage at this point. If we have the voltage at this point, so what is the Vi? Vi is given as 2 volt. 2 volt. According to virtual short concept, Vp is equal to Vn is equal to 2 volt. And therefore the voltage at this point is what? 2 volt. Then to find the V0, we can apply the KCL at this point as well as at this point, or remember this is a non-inverting operational amplifier. Therefore directly we can say V0 is equal to 1 plus Rf by R1 into Vi. 1 plus, what is the Rf? 1, R1 1, this is 1, into Vi is 2, and it will become 4 volt. You will get the 4 volt here. This is the output because it is non-inverting operational amplifier. This is normally it is called RL. Now what is the I0? Write down the KCL at this point. So I0 is the incoming current. And what is the outgoing current? V0 minus Vi. What is the voltage at this point? V0 minus 2 volt. Divided by 1 kilo ohm plus V0 minus 0 by 1 kilo ohm. So this is 4 minus 2 divided by 1 plus 4 by 1. This will become 6 milliampere. 6 milliampere is the current through this branch. Right? So that is the answer is what? 6 milliampere. Dreamer, very good evening. How are you? Now, so that is the 6 milliampere. So simple question. Directly we can solve this question. Right? But remember, what is the use of this? What is the use of this figure? One thing. Then watch this diagram. Give me 1 minute. Okay. Always remember, this is the RL. And when Vs is connected here, like this question, here we are getting the V0. This is 1 kilo ohm, that is the 1 kilo ohm, this is the ground, this is the 1 volt. Okay, and that this is the 2 volt, sorry, 2 volt, and that's why we are getting the 4 volt here. Now if suppose I am changing the value of RL, if I am changing the value of RL, the output will remain same. Voltage will not affected. There is no loading effect. This is the RF, this is the R1, and the gain is independent of what RL. 1 plus RF by R1 into what VI. But when we are changing the value of the current, already we have solved. So what is the I0? I0 is equal to V0 minus Vi upon RF plus V0 upon RL. V0 minus Vi, because virtual short concept, so V0 minus Vi upon RF plus V0 by RL, that is the current. But when I am changing the value of RL, suppose I am decreasing the RL, what about the current? I am decreasing the RL, the current given by the operational amplifier increases. Current given by the operational amplifier will increases. But the output will maintain at what? 4 volt. 4 volt. And that is the capacity of the operational amplifier. This is the internal diagram of the operational amplifier. Okay. And that is the purpose of the amplifier. Jitni aapko current ki zarurat hai, that is provided by the operational amplifier. So this type of questions they may ask, because it is the part of what? MSQ. Part of MSQ. Remember one thing. Next one. Now, this is a very, very important diagram. Amplifier. We are taking the output from the emitter, right? And that is, so this is a simple amplifier. What is the answer? It is a common emitter with bypassed RE. Common emitter with bypassed RE. In GATE 2020, then for the BJT in the amplifier shown below, let the VB is 0.7 volt, KT by Q means VT is 26 millivolt. Assume that BJT output resistance is very high, means almost infinite. The base current is negligible. The capacitor are also assumed to be short circuited at signal frequencies. All the coupling capacitor act as what? Short circuit, bypass act as short circuit. Input VI is direct coupled, means we are not using any capacitor here. The low frequency voltage gain V0 by Vi of the amplifier. Simple voltage gain is asked. Low frequency voltage gain is asked in this question. Right. Now, remember one thing. For this diagram, this is a standard diagram for this one. Suppose this is the case. This is a standard diagram, okay? RC, and we want V0 here. This is the RE, unbypassed RE, for example. There is only one formula. Let this is the internal resistor RE. You have to calculate the RE. And this is the VCC is applied here. This is the RC, this is the RL, this is RE, and this is the capital RE, unbypassed RE. For this question, here we are applying the input. So what is the general answer, electrical electronics student? Remember this formula. The V0 by Vi, that is called small signal gain. Its general formula is minus RC parallel with RL. Minus RC parallel with RL upon small re plus capital RE. Small re plus capital RE. That is the formula only. This is the one formula. Right. Now remember one thing. A, what is the small re? Small re is given by Vt by IE. I is the DC biasing current. Okay. If suppose this capital RE is bypassed by the capacitor. If the capacitor is connected here, then this capital RE will become 0 because it is short circuited by the capacitor. Then what is the formula? Minus RC parallel with RL upon small re. This one. That capital RE will become 0. Right. Second thing. If it is unbypassed, then in case of unbypassed, normally the capital RE is very, very greater than small re. In that case, what is the approximated answer? Minus RC parallel with RL upon capital RE if it is unbypassed. Bypassed, then small re. Third important thing, if in a particular numerical, if RL is not given, for example, RL is not given, then RC parallel with infinite, it is become RC. Not given means what? RL is open circuit. So RC parallel with infinite is what? RC. So there are only 4 cases. Bypassed RE, unbypassed RE, with RL, without RL. And that is the standard answer for this question. Now, in this numerical, we have to calculate the small re because capital RE is bypassed. Now if the capital R is bypassed, what is the DC analysis of the diagram? Now we are going to do the DC analysis for this diagram. So what is the DC analysis? In a DC analysis, capacitor will act as open circuit. Then this is the case. And this voltage is minus 10 volt. During DC analysis, AC signal will 0. This is the direct coupled, so that's why it will act as 0. And this capacitor will act as open circuit. This is the RC. This is 10 volt. This voltage is 0.7 volt. And this is 10 volt. And what is the value of the RE? 20 kilo ohm. 20 kilo ohm. And this is the IE. Now write down the KVL here. When I am writing the KVL, in this loop, write down the KVL. 0 is equal to 0.7 plus IE into RE minus 10. So what is the IE is equal to 10 minus 0.7 divided by RE. What is the value of RE? 20 kilo ohm. It will become 9.3 divided by 20 milliampere. This is the IE. Now what is the small RE? Small RE will become VT by IE. Value of VT will be given in the question, that is the 26 millivolt. 26 millivolt divided by 9.3 divided by 20. Milli cancel out. And you will get the small RE. What is the value of the small RE? Now you can find the value. Okay, tell me. So it will become 20 into 26 divided by 20. No, sorry. 26 into 20 divided by 9.3. 55.914 ohm. Nearly equal to this one. So what is the gain? Already I have given you the shortcut. No need to make the model and so on. So the gain will become minus RC parallel with RL. 10 parallel with 10. This 10 parallel with this 10, and small RE because it is bypassed. What is the small RE? 55.914. 914 into 10 raised to power minus 3 because it should be converted into what? Kilo ohm. Then 10 into 10, 5 into 10 raised to power minus 3 divided by 55.914. Please find the value. This will become plus 3, 5000. Now you can get the value 5000 divided by 55.914. 89.4. 89.4 is the value for this question. Minus, because this is a common emitter, therefore 180 degree phase shift. 180 degree phase shift. So this is the general formula, minus RC parallel with RL upon small RE. Finished. No need to draw the small signal model for this particular diagram. Okay. Next question. Now, an enhancement MOSFET of threshold voltage 3 volt is being used in the sample and hold circuit given below. This is a sample and hold circuit. Here we are using the switch. This is the MOSFET act as a switch, right? It is also called chopper. That is, ये है chopper और ये है, this is better than what? BJT. An enhancement MOSFET of threshold voltage 3 volt is being used in sample and hold circuit given below. Assume that the substrate of MOS device is connected to minus 10 volt. Means we want to make it what? Source body junction and drain body junction is what? Reverse bias. If the input voltage V1 lies between plus minus 10 volt, this is the plus minus. So what is the range? Minus 10 to plus 10. The minimum and maximum value of Vg required of the proper sampling and holding respectively are. Right? That is the question. Sample and hold circuit. So this is the question from electronics. Then simply draw the diagram. Now what is the signal required here? Minimum and maximum signal. This is the V1. 10 to minus 10. Now try to understand. This is the switch. This is the switch. When it is on, it will act as short circuit. When it is on, it will act as short circuit, means capacitor will charge up to what, like 10 volt. For example, it will act as what, 10 volt. Right? No doubt, it is charged up to what, 10. At that time, this transistor should remain what, on. At that time, the transistor should remain on. So what is the threshold voltage at this point? The threshold voltage at this point, the minimum threshold, that threshold voltage is given as 3 volt. Vt is given as 3 volt. You have to maintain the minimum voltage at this point, that is the threshold voltage, so the transistor or MOSFET will remain in on position, because it will try to make it what, off. Now we are writing what is the VTH? VTH is equal to VGS, VG minus VS, and this is the VS, voltage across the capacitor. Vg minus 10, it should be greater than threshold voltage 3 volt, greater than or equal to. So what is the Vg? Greater than or equal to what? 13 volt. You will get in the one range, that is the 13 volt. Right? Itna to hona chahiye. Right? Second thing, so which answer? 13 volt is one answer only. Then directly you can put here. But how we are going to find the second value? Then in second case, if it is minus 10, the capacitor will charge up to minus 10 volt, because it will act as short circuit. Now this is the Vg, this is the Vt. Tell me again, Vt is equal to Vg minus Vs, that is equal to what? Minimum, that should be equal 3. So what is the Vg is equal to? 3 minus 10, that is minus 7. This is the minimum value of the Vg. Okay, minus 7 and what? 10. That is the answer. So sample and hold circuit we are using to sample the signal. So normally we are connecting voltage follower in front of this sample and hold circuit to reduce the effect of loading again. So which type of circuit we are using? This is the capacitor, that is the sample and hold circuit, but here we are using the voltage follower. And then we are connecting ADC, analog to digital converter here. So that may be the question, integrated question. Here we are giving the input. Then this is the switch, MOSFET. And then we are connecting one capacitor here, then voltage follower here, and then analog to digital converter here. So that is the diagram. So that the analog signal is converted into what? Digital signal. That is the diagram. Okay. Here we are giving the analog signal. We are using the sampling, right? And what is the input resistance of this buffer? Infinite. Okay. If suppose we are directly connecting the capacitor here in this diagram, if suppose I am directly connecting the capacitor in this diagram, resistor in this diagram parallel to what? Capacitor, then the capacitor will discharge through this. Capacitor will discharge through this, right? This is clear? No, I am not taking the Vg as a plus 10. No, I am not taking Vg, I am taking the V1 is equal to, 1 minute. I am taking the Vs, voltage across the capacitor. That is the voltage across the capacitor. That is the Vs. Vg minus 10, that is greater than or 3, and that is Vg equal to what? 13 volt. Right? So that it will remain in on position. Right? Here capacitor, what is the minimum voltage across the capacitor? 10 volt, and what is the maximum voltage across the capacitor? 10 volt. In both the cases, voltage between the gate to source should be what? Vt. Should be Vt. Okay. देखो एक कॉन्सेप्ट हो गया ये. अब आते हैं, देखो दो चीजें हैं. let's try to understand. ये तो हो गया sample. So this is the case. So when we are connecting the voltage follower here, what will be an input resistance? Ra is equal to infinite. Therefore, this capacitor will not discharge through the capacitor. Suppose it is charged up to what, 5 volt. But in this case, that there may be the probability that this capacitor will discharge through the load. But once we are connecting the voltage follower here, this capacitor will not discharge. It will hold the value. It will hold the value. There is some propagation delay. After some time, this analog to digital converter will convert it into what? 101. That is the code for 5. That is the code for 5. That is the use of this circuit. Okay. तो देखो logically क्या है? Simple ये है. Suppose capacitor is charged up to what? Minus 10 volt. Now it will try to make it what? On. Why it will try to make it what? On. When we want the MOSFET should remain off. So what is the VG and VS? Suppose I am putting here 0. Suppose I am putting the VG is equal to 0. Let it is grounded. Let it is grounded. I am saying that the minimum value is 0. But when it is 0 and when it is charged up to minus 10, what is the value of VGS? My dear, VGS will become VG minus VS. That is what? 0 minus of minus 10. It will become 10 volt. Or 10 volt is greater than what VT. And that's why the MOSFET is on. But I want the MOSFET should remain off. MOSFET should remain off. In that case, MOSFET, when the MOSFET will remain off, when the MOSFET will remain off, when I am giving not a 0 voltage, I have to apply the voltage so that this voltage should be less than or equal to VT, transistor will remain off. And therefore, I am calculating VGS is equal to VG minus of minus 10 volt. It should be less than or equal to VT. So VG minus plus 10 volt. It should be less than or equal to 3. So VG should be less than what? Minus 10 volt. Minus 7 volt. So we are taking the minimum value minus 7 volt equal to. That is the case. When I want to make it what? Off. So this is the off condition. It should be less than or equal to minus 7 so that it will remain off. In second case, when this is 10 volt, 10 volt, it will try to make it off. But at that time I want it should on. So what is the condition so that the transistor will be on? So what is this? VGS should be greater than VT. VG minus V8 should be greater than or equal to VT. So what is the VG minus 10 should be greater than or equal to VT. What is the VT3? So VG should be greater than or equal to what? 13. So that transistor will be on. So what is the maximum value? 13. What should be the range? Minus 7 to what? 13. Minus 7 to what? 13. Okay. So that is the case. So in this way, right, try to understand the question. Don't try to mug up. Don't try to mug up the question. Okay. आपको कुछ भी पूछा जा सकता है, आपको समझ में आना चाहिए कि कैसे बनाना है. अब अगली बार they will ask MSQ something, what is the condition and so on. So this is a sample and hold circuit, that is the use of the voltage follower. Now next question. Now that is a question on what? Simple MOSFET. What is the Norton's equivalent? Using the incremental low frequency small signal model of the MOS device, the Norton equivalent resistance of the following circuit. So in this case, you have to draw the small signal model, and during a small signal model, all the DC sources will act as what? 0. This will act as 0. Now, here, this is the source, this is the drain, this is ground. Here we have to calculate the Norton's resistance. Then GM is the transconductance, VGS is the gate between, and this is the R0 or RD. What is given here? RDS. Drain to source resistance. This is the drain terminal and this is the source terminal, and that is the gate terminal. Right? Now this gate terminal is connected to what? Ground, and that's why this voltage is 0. That is the ground. And from drain to ground, R is connected, because this is the drain, that is the ground, R is connected here. Okay, this R is connected here. Now between source terminal and ground terminal we have to find the RL, and this is the VGS. Remember, always remember, one there is a dependent sources. This is the VGS. Plus minus, this is the VGS from this point to this point. No doubt this is the input resistance is infinite, that's why this will act as open circuit. So VGS is equal to, now since there is a dependent source and you want the resistor, Norton's or Thevenin's resistor, same thing, then here we are connecting one external battery. Let the value of this battery is 1 volt, and because of this the current is I. So what is the Norton's resistance? The Norton's resistance will become 1 by I. Now remember one thing, what is the current distribution? This is 1, this is I, this is GM VGS. So write down the KCL at this point. This is the incoming, this is the incoming. So what is the outgoing? I plus GM VGS. Okay, and now again distribution, the GM VGS here. So what is the current here? I only. So what is the current here? I. What is the current here? I. Now loop is completed. Now what is the VGS? Write down the KVL in this path. KVL in this path. So when I am writing the KVL in this path, this will become VGS plus minus VGS plus 1 volt. Plus 1 volt is equal to 0. So what is the VGS is equal to minus 1 volt. So this will become I minus GM. I minus GM. Now write down the KVL in this path. KVL in this path. So when we are writing the KVL in this path, you will get the 1 by I. So what is the KVL? Very easy question. Minus 1, this is the minus 1, plus I minus GM. Because VGS is equal to minus 1, it is already converted. I minus GM into RDS plus I into R. KVL is over, is equal to 0. You have to find a 1 by I, so you will write, and this will become I RDS plus R is equal to minus will become plus, this is the will become plus, and this minus GM RDS will become plus. GM RDS will become plus. So what is the 1 by I? From this you will get the 1 by I is equal to R plus RDS upon 1 plus GM into RDS. Very simple question. And this output resistance is very, very low value. Very, very low value. And this is a, when we are taking the, here it is a common drain. And for common drain, the output resistance is very low. For common drain, the output resistance is very, very low. So when we are taking the output from the source, this is called common drain. Common drain configuration, or it is also called source follower. For this circuit, the resistance, output resistance is very, very small. That is what, that is divided by what? 1 plus GMRD. One GMRD is called mu, amplification factor in case of FET, junction field effect transistor. It is GMRD, mu, amplification factor. And that's why the output resistance is what? R plus RDS upon what? 1 plus mu. Now, they will ask, normally this resistor is 0. It is a, we are connecting the RL here and we are taking the, normally this resistor is 0, we are taking the output from the source. Means when we are connecting the R, what will be the question? When we are connecting the R, what about the output resistance? It will increase or decrease? When we are connecting the R, the resistance will increase because it is in denominator. Because this is nothing but drain resistance. This is nothing but drain resistance. So sometime it is not, if it is not given, then this R 0, so RDS upon 1 plus mu, right? RDS upon that is I am giving you the another shortcut. Remember one thing. देखिए, if suppose this RD is not given, means it is 0. So what is the output resistance? RD plus RDS upon 1 plus GM RDS. Okay, that is the answer. If this is not given, short circuit, so what is the resistance seen here? It will become RDS upon 1 plus GM RDS. This term is very, very greater than 1. When this term, this is nothing but mu, amplification factor is very, very greater than 1. You can neglect the 1 or it is nearly equal to what? 1 by GM. So in a GATE exam, already one question in electrical branch. What is the question? What was the question? This type of questions. Remember. This is connected here, something 3 kilo ohm, and the GM is given here. Right, something value of the GM is given, right? And then you have to find what? You have to find the output resistance here. Simple question. This is the input is connected here and find the output resistance. So number of students have given the 3 kilo ohm is the answer. 3 kilo ohm as the answer. But what is the answer? Why, my dear, you have to find the, first of all, R0 dash here. This is R0 parallel with R0 is the output resistance. R0 dash parallel with that. So what is this R0 dash? Only GM is given. So already I have given now. What is the answer? 1 by GM. So up to this point, Thevenin's or Norton's resistance is 1 by GM. This 1 by GM parallel with the 3 kilo ohm is the value of R0. 1 by GM parallel with the RL. This is called RL. Is the answer for R0. Okay. So this is a 1 mark question. So in this question, no doubt we are solving this GM-RD and we are finding. But what is the, if RD is not given, it is approximately equal to what? 1 by GM. Remember this point. Okay. So this is all about. तो भाई सीधा मेरली उस क्वेश्चन को सॉल्व करने की कोशिश मत करो. क्या हो गया विश्वनाथन मुरली? केवीएल इन फर्स्ट स्टेप. व्हाट इज केवीएल? तो क्या हो गया बताओ, कहाँ गया केवीएल? यस, हाँ बताओ. देखो, व्हेन आई एम राइटिंग द केवीएल, तो प्लस VGS प्लस 1 इज इक्वल टू 0. तो व्हाट इज द VGS इज इक्वल टू -1 वोल्ट. -1 वोल्ट. दैट इज क्लियर. नाउ व्हेन आई एम राइटिंग माइनस, तो भाई VGS इज इक्वल टू माइनस. So -1, so it will become plus, will become minus. I minus GM. That is the correct one. I plus GM, VGS is converted into I minus GM because VGS is already, I have proved, -1 volt. Write down the KVL. -1. I have written -1. Y minus GM into RDS plus I into R. KVL is over. Okay. चलिए next one. तो देखिए इस टाइप का, ये देखो प्रीवियस ईयर में ये भी क्वेश्चन आया, सेम क्वेश्चन. तो रिपीटेटिव नेचर वी कैन से इन 2007 और 8 दिस इज द क्वेश्चन. तो इन 2019 दैट इज द क्वेश्चन. मान लो 1920. तो भाई रिपीटेटिव नेचर है ना, वी आर गेटिंग द सेम क्वेश्चन ऑन सेम टॉपिक, सिमिलर टाइप ऑफ क्वेश्चन. देन ऑपरेशनल एम्पलीफायर. द कंपोनेंट्स in the circuit given below are ideal. All the components are ideal, means capacitor is ideal, resistor is ideal, operational amplifier is ideal. If R is equal to 2 kilo ohm, this R is 2 kilo ohm, this R is 2 kilo ohm, C is 1 microfarad, this is 1 microfarad. The 3 dB cutoff frequency of the circuit in hertz. 3 dB cutoff frequency of the circuit. Okay, there are number of components, right? But when all are ideal, there is a negative feedback. There is a negative. What will be the answer? Give me the answer in comments box. So this is when number of components are here, an ideal operational amplifier, there is a negative feedback. What about the virtual short concept, virtual ground process? Virtual short concept or virtual, what is virtual ground process? Virtual ground is a special case of what? Virtual short. Because the gain of the operational amplifier is infinite, that's why the voltage at this terminal is equal to voltage at this terminal. If it is 2 volt, it is 2 volt, it is 3 volt, it is 3 volt. If it is 0 volt, it is 0 volt. Means virtual short concept, virtual ground process is a special case of virtual short concept. Okay. Then Then if it is 0, tell me, if it is 0, it is 0. What is the current through the 2R? 0. What is the current through this capacitor? 0. To remove this, so this is a nothing but low pass filter. And for low pass filter, what is the cutoff frequency? Depend upon this C and this RF. So omega C cutoff frequency, that is the 2 pi FC, is equal to 1 by RFC. RFCF. CF means the capacitor connected in feedback path. This is RF and CF are connected in between input and output, and that is called feedback path. So what is the value of R and C? R and C. R is given as 2 kilo ohm. C is 1 microfarad. Or it is asked in what? 3 dB cutoff frequency in hertz. So in hertz it will become 1 by 2 pi R C. 1 by 2 pi into R. 2 kilo ohm. 1 microfarad. So it will become 1000 divided by 4 pi. 250 divided by pi. 250 divided by pi. 79.57 hertz. 79.57 hertz. That is the answer D. So this is a low pass filter, standard circuit of low pass filter. 2R सर जानवी भार्गव क्यों रिमूव हो गया? अच्छा जानवी एक बात बताओ, ये एक मिनट इस डायग्राम को देखते हैं ना, वापस देख लेते हैं, मैं बताता हूँ अभी ना, 1 मिनट. Right, watch this. Virtual short concept means what? It is ideal operational amplifier. There is a negative feedback. So this voltage is 0, this voltage is 0. So what is the drop across this resistor 2R? Here the voltage is 0, here the voltage is 0. So what will be the current through this? 0, and that's why we can remove it. Similarly, what is the voltage across the capacitor? This is the negative terminal, that is 0. So what is the voltage across this capacitor? 0. So what will be the current? 0. There will be the no change, and that's why we can remove. Okay, that's why we can remove. Remove it. Oh, you are giving that, sir, 0 voltage, then what is the? No, because of the 0 volt, what will be the current through that branch? No, you are thinking about the Viswanathan Anand, you are saying that 0 volt means what? That should act as what? Short circuit. No. I am saying that the voltage across this terminal is 0. So what will be the current through this branch? Current will be 0. So what operational amplifier based on the KCL I, the current will flow. What is the current here? 0. What is the current here? 0. The same current will pass through this I1, I2. And when I am writing the KCL at this point, it will become 0 minus Vi by R plus 0 minus V0 by RF plus 0 minus V0 by, what is the impedance because of the capacitor? 1 by SCF, or is equal to 0. So what is the current through this branch? 0. What is the current through this branch? 0. Write down the KCL at this point, 0 minus EI. So you will get the standard formula, and from the standard formula you will get the cutoff frequency. That's why we are removing. Now it is clear why it is act as what? Open circuit, because there is no current. There is no current. Right. So remove this too. Okay, next one. Next question. In the voltage regulator shown below. So normally we are having the different types of voltage regulator: series voltage regulator, shunt voltage regulator, standard circuit, voltage regulator by using operational amplifier, voltage regulator by using what? Zener diode. That is the resistor. We are having the 2 transistor here, 1 transistor here, 1 transistor here, 1 Zener diode is here, right? Always remember, in any voltage regulator, BJT should be in active region, then it will work. So both the BJTs are in active region, and Zener diode should be in what? Breakdown region. breakdown region. Once the BJT will be in active region, voltage across that base and emitter VB will be 0.7 volt and voltage across the Zener diode will be VZ. That will provide you the constant voltage. So that is the condition for satisfactory operation of the circuit. In this question it is given V0 is the 9 volt. In the regulated voltage V1 is the unregulated at 15. Here it is the unregulated voltage 15 volt. VB is 0.7 volt and the base current is negligible for both the BJT. If the regulated output voltage is 9 volt, the value of R2. Very simple, very simple question. Right, very simple question. R2 you have to find. So what is the R2 here? Now to find the R2, remember this current is what? 0. Base current is 0. This base current is 0. Beta is very large. Now the voltage across the Zener diode is 3.3 volt and voltage across this BJT is what? 0.7 volt. So what is the voltage at this point? Vx. So write down the KVL here from this point to this point. When I am writing the KVL, it will become Vx is equal to 0.7, that is the VBE plus VZ. 0.7 plus what? 3.3. That is 4 volt. Vx is 4 volt. So at this point, according to voltage division rule, what is the Vx in terms of V0? Vx will become R2 upon R1 plus R2. R2 upon R1 plus R2 into V0. This is given as 4 volt. R2 is, you have to find the R2. What is the R1? 1 kilo ohm. What is the V0? 9 volt. 4 plus 4 R2 is equal to 9 R2. So 5 R2 is equal to 4. Right? What is the R2? R2 is equal to 4 by 5 kilo ohm. 0.8 kilo ohm. It is multiplied with the 1000. It is 800 ohm. It is a 800 ohm. Right answer. Yes, Murli, your answer is correct. 800 ohm. ओके तो ये है बात. चलिए अब आते हैं नेक्स्ट क्वेश्चन पर. एंड देखो ये है स्टैंडर्ड सर्किट ऑफ वोल्टेज रेगुलेटर फॉर एग्जांपल, राइट. स्टैंडर्ड, नो डाउट R2 is asked, no problem, but sometimes that is V0 is not given. For example, what is the V0? Now in this case, first of all remember that Zener diode is given, 0.7 is given, then this Vx is given, R1 and R2 is given. So first of all find the Vx. So Vx will become VB plus what? Vz. That is constant. That is constant, VB plus Vz. It is independent of what? Vi and independent of what? RL. We are connecting RL here. Okay. Then according to voltage division rule, what is the relation between Vx and V0? Vx is equal to R2 upon R1 plus R2 into what? V0. So what is the V0 is equal to R1 plus R2 upon R2 into what? Vx. This will become 1 plus R1 by R2 into Vz plus VBE. And that is R1 constant, R2 constant, Vz constant, VBE constant, and that's why the output voltage will remain constant. It is independent of variation in RL. It is independent of variation in what? 15 volt. And therefore it will provide what? Line regulation as well as load regulation. Line regulation as well as load regulation. Both is provided by this. Second question, this is a standard diagram. And that's why they may ask what is the power dissipation across the transistor. So once it is the power dissipation is asked, for example, you have to calculate the VC. So first of all, with the help of R1 and R2, find the value of the V0. You can find the value of the V0. Once you will get the value of the V0, then this is the unregulated voltage, that is the regulated voltage. Always remember during calculation of the power, get the maximum value of the input. Sometime it is a variation, for example 15 to 20 volt. Always take maximum value. Maximum minus V naught. This will give you the VC. VI max minus V naught. This will give you the VC. Then what is the value of the IC? The base current is normally negligible. So IC is equal to I. What is the I? The current through this R1 and R2 and current through this RL. So I will become, I is equal to IC will become V naught upon R1 plus R2 plus what? V naught upon RL. V naught upon RL. V naught upon R1 plus R2 plus V naught upon RL will give you the value of I. Once you will get the value of I or IC, you can calculate the power dissipation. What is the power dissipation? VCE into IC. That is very, very important one. No? Very important one. VCE into IC. What is the power dissipation across this transistor? This transistor. What is the power dissipation across this transistor? Okay. So that is the question. You have to find the answer for this one. Okay. Easy guys. Pura. Try to solve every type of question, because they may repeat the same question, same diagram. But this time they will not ask R2. They will ask what is the power dissipation across this transistor, what is the power dissipation across the Zener diode, right? Then what is the power dissipation across this transistor, this one, VC. You have to find the VC at this point. Then you can find the power dissipation across this one, right? What is the IC current here, right? So sometimes it will become very, very lengthy question. Let this is the IB, beta is given here, let this is the IC, this let the transistor 1, this is the transistor 2, what is the IB2, IB1, and then find the current through the Zener diode, then you can find the power dissipation across the Zener diode. VZ into IZ. Okay guys, so that is the case. That is the case. Okay. पूरा फाइंड कर लेना जरा. चलो आगे देखते हैं नेक्स्ट कंडीशन. अब टेस्ट सीरीज आप देते हैं ना, you are giving test series, yes or no? So you are giving the test series. Now I will make one question on that. Find the power dissipation. Same type of question, and I will give to you are satisfied with it. Yeah, we all are engineer. We can also anticipate the question. Find the power through the Zener diode, power dissipation across the Zener diode. Find the power dissipation across this transistor. Find the power dissipation across this transistor. So I can frame around 10 to 20 question on the same diagram. 10 to 20 question on the same diagram. So if suppose you want to get the top rank, we have limited time. We can give only one or two what test series we can join. To join the authentic test series. Then when we are solving the previous year question, try to design the question. Which type of questions they may ask in 2023 or 2024. That is this time. Same diagram. Next time what will be the question. Right, and then try to solve that question. Okay. This will help you. Then next, a common source amplifier. Again, common source it is equivalent to common emitter with a drain resistant RD is powered using a 10 volt power supply. Assuming that the transconductance is 520 microampere per volt, the voltage gain of the amplifier is closest to. Here in electrical branch, normally they are not giving the diagram and they simply want the answer. But what is the common source? This is the RD. This is the standard diagram. Here we are giving the VI in gate terminal. Here we are getting the output. And here we are giving the supply. So it is powered using a 10 volt power supply. This is the 10 volt. And what is the RD? 4.7 kilo ohm. Right. The voltage gain of the amplifier is closest to. So what is the voltage gain of the amplifier? You are giving the answer A. Yes. Remember the phase shift is 180 degree and the voltage gain for this circuit is, that is called midband voltage gain, minus GM RD parallel with small rd. So RD is given. Small RD means when we are considering the channel length modulation, there will be a small RD. But a small RD is not given in the question. You can take it what? Infinite. If the small RD is not given, you can take it what? Infinite. So it will become minus GM capital RD. Now what is the GM? 520 microampere. Convert it into milliampere. 0.52 milliampere per volt. Milli is cancelled with the kilo. So that's why it will become very easy. Minus 0.52 into 4.7. Minus 0.52 into 4.7 nearly equal to this 2.44. That is the answer. 1 mark question, electrical students. Similar type of question from BJT. Similar type of question from what? MOSFET. Standard circuit. Standard answer. GM RD. Minus GM RD. GM is the transconductance, RD or small RD, capital RD. If small RD is not given, that is the drain resistance due to channel length modulation or output resistance, then simply take it what? Infinite. Okay, then next one. Okay, that is again electrical branch, 2 mark question. A non-ideal diode is biased with the voltage of minus 0.03 volt. Always remember, if the diode is given, it is talking about this voltage. And that is the current. And we are having the formula. This is the current formula. When this is the plus minus polarity, and that is the I, and that is the current through the diode. That is the formula for the diode current. A non-ideal diode is biased with a voltage of minus 0.03 volt, means this is the negative value. If it is a negative value, means that diode is what? Reverse biased. And a diode current of I1 is measured. Okay, the thermal voltage is 26 millivolt, Vt is 36, and ideality factor of the diode is 15/3. Normally we are saying that ideality factors are 1 for germanium, 2 for silicon. Right, but my dear friend, when we are increasing the current for rated current it is 2 for silicon. For very high current it will become 1, or it is between 1 and what? 2. It is between 1 and 2. It is a practical value. Ideality factor for diode is 15/3. The voltage in V at which the measured current increases to what? 1.5 I1 is. When the current will become 1.5 times of I1. You have to find the value. So which answer is correct? This is a 2 mark question from electrical branch, right? Then remember, the diode current is given by I naught e raised to power V by eta Vt minus 1. Okay, when I is equal to I1, I naught, it is given as minus 0.03. Minus 0.03, and what is the value of the Vt? 26 millivolt. It is in volt. You can convert it into also volt. It will become, so what is the value of the eta Vt? Eta Vt will become 15/13 into 0.026. That is converted into volt. It will become, I think, 0.03. Check this. It is also a 0.03. Put here 0.03. Minus 1. So this is I1 is equal to I naught e raised to power minus 1 minus 1. So number of students will neglect the 1 for approximate answer. But remember, it is reverse bias, and that's why you can't neglect this one. You can't neglect this one. It is 1 is neglected. We are neglecting. But when the diode is what? Forward bias. When the diode is forward bias, this quantity is very, very greater than 1. But here it is less than 1, e raised to power minus 1. If suppose we are neglecting the one, that we are getting wrong answer, wrong approximation. Okay. Now, what is the e raised to power minus 0.368? As you know, minus 1, 0.368 or 3678 minus 1. So you will get I1 I naught. That is the value I1. Now what is the second case? What is asked here? The voltage in volt at which the measured current increases to 1.5 times of I1. 1.5 times of I1 means, now again, now the current is 1.5 times of I1 and you have to find out what is the value of the voltage V. Again you are applying the same eta Vt minus 1. Now 1.5 times of I1, what is the value of I1? Minus 0.632 into I0 is equal to I0 e raised to power V. We have to find, already we have calculated the eta Vt. Eta Vt is 0.03 minus 1. This I0 is cancel out. This one will become plus 1 plus what is this value? 1.5 into 0.632, that is 0.948. So it will become 1 minus 0.948 is equal to e raised to power V by 0.03. So what is the V is equal to 0.03 log of, what is the difference? 0.052. Take the log of this into 0.03. So you will get answer minus 0.88. This is nearly equal to minus 0.0. 0.09 volt. That is the answer. Which answer is correct? This one. Minus 0.09 volt. Good question in 2 marks question, right? In exam hall, be careful. In both the cases, the diode is what? Reverse bias. And remember one characteristics that you can give the answer for this one. Right? What is the answer? Minus 4.50 minus, all are minus. Right? So that is the characteristics of the diode. Since it is reverse bias, this is the case. I am just zooming it. Right? At this point it is I0. Okay, but what about this portion? This is less than I0. So when we are increasing the voltage before saturation, initially the voltage is 0.03. Now this point the voltage is 0.09. We are increasing the voltage. This is the current is I1. This current is what? 1.5 times of I1. Both are negative. Both are negative. That is the case. We are increasing. Okay. Okay then. So that is the value. Next question. Now same similar question in 2019 in electronics. This is the question in what? 2020. 2 marks electrical. And that is the question in what? Electronics branch. An ideal PN junction with an ideality factor of 1 at 300 degree Kelvin. The magnitude of the reverse bias voltage required to reach 75% of its reverse saturation current rounded up to 2 decimal places is. Please try to solve this. This is the homework. Already I have solved this in what? EDC. Electronics student, go through my EDC session. You will get the idea or answer for this question. Similar question. Again, in a 20 and 19 and what? 20. Same question. Okay then. बस यहाँ पे लिखे 75% of its reverse saturation current. So directly apply the formula, you will get the answer. And this Boltzmann constant, everything is given. From this you can find the Vt. What is the Vt? Kt by Q. Kt by Q. Now, another one, another question. भाई आप लोग भी आंसर बताते रहिए जरा क्या हो रहा है, तो आप कमेंट्स भी कर सकते हैं. अगर आपको कोई चीज अगर समझ नहीं आ रही है तो आप पूछ सकते हैं. ओके, कोई भी दिक्कत या डाउट है आप तो आप आराम से पूछिए. राइट, अब देखो, इन द सर्किट शोन Vs इज अ स्क्वायर वेव. दिस इज अ स्क्वायर वेव ऑफ पीरियड t with maximum and minimum value of 8 volt and minus 10 volt respectively. Assume that the diode is ideal, that this diode is ideal, and R1 and R2 are 50 ohm. This is 50, this is 50. The average value of VL is average. You have to find the average value of the VL, right? Now, tomorrow you can join one session. Already we have conducted the mock test on BYJU'S Exam Prep app. You can join, where I will solve what? Questions from the mock test. So, good questions from digital electronics, good question from analog, questions from what? Network, and question from what? EDC. I will solve from the 4 subject. 11:30 and then what? 1. So, hardly 30 to 45 minutes morning. It is a morning session and it is a very new question, right? All questions are new, right? And you will get some idea how to solve the questions. So, tomorrow morning free classes, right? Free classes on app. So, you can join, right? And simple आप download कर लीजिए और अभी कर लीजिए तो कल morning में 11:30 पर AM. Then second session is 1 AM, 1 PM. So we are going to solve around 10 to 20 questions, new questions from mock test. Then in the circuit shown, Vs is a square wave of period T with maximum and minimum values of 8 volt and minus 10 volt respectively. Assume that the diode, this one, the average value निकालना. How we are going to find the average value? बताइए, what is the answer? Or if you want the link, then I am sharing on my Telegram channel, that is Electronics by Sanjay Rathi. Please join that so that you will get the notification about that free class. Okay. Now try to understand. It is an ideal diode when we are in the positive half. The current will pass through this. Current will not pass through this because it will not allow the current in reverse direction. That's why the diode is what? Off. So during the positive half, the diode is off. So what about the diagram? Diode is off. That's why we are having the 2 resistors connected in series. And here we are having the 8 volt because during positive half it is a constant volt. And both the resistors are equal, and that's why output is divided into 2 parts, 4 ohm, 4 volt, and therefore the output is 4 volt. So simple case, during positive half the diode is what? Off. That's why R1 and R2 are in series. The given value of R1 and R2 are equal, 50 ohm, 50 ohm. Therefore the output is what? 4 volt during positive half. Now what about the negative half? When we are giving the minus 10 volt, minus means this is plus, this is minus plus 10 volt. What is the direction of the current? The current will pass like this through diode and complete the circle. So through diode means, yes, diode will allow the current from P side to N side. So this will act as short circuit. It will short circuit the resistor. When it will short circuit the resistor, what is the output? Output is exactly replica of the input in reverse bias. So what is the output? Minus 10 volt. Minus 10 volt. So during positive half it is 4 volt. During negative half it will become minus 10 volt. So now watch this diagram. How we are going to calculate the average value? This is a square wave. Symmetrical square wave, on period is exactly equal to off period. And that's why this is T by 2. This is T. What is this gap? T by 2. T by 2. This is the output. 4 volt highest value, minus 10 volt is the lowest value. So simply we can find the area divided by what? Time. That will give you the average value. Or simply, what is the area? T by 2 into 4 plus minus 10 into T by 2. So this is the positive area area of this rectangular t by 2 minus 10, area of this rectangular t by 2 into 4 upon what? Total time period. What is the total from this point to this point? T. So t cancel out, it will become 2 minus, this is the 2 minus 5. What is the average value? Minus 3. Average value is minus 3 volt for this question. Now, student will integrate it, but it is a simple square wave. Why you want to integrate it? During one period, you have to integrate the signal. Right? Yes. You can also integrate. You are going to get the same answer from this average value. This is the general formula for average value. Okay, again you will get the minus 3 as a answer. Minus 3 as a answer for this particular question. Okay guys, this is clear. कोई doubt है तो पूछ लो इसमें. No doubt. Forward bias and what? Reverse bias. Only 1 mark question. 1 mark. Within 1 minute or 2 minutes we have to solve. 1 mark question. Next, that is from electronics branch. Again, this is the question from the electronics branch. MOSFET, right? In the circuit shown, the threshold voltage, last year again same similar type of question, right? 2019 similar question. Again there was a one capacitor, you have to find the voltage. Yesterday I have solved that question, right? कल ही हमने solve किया है और आज फिर देखो 2019 में यही question आया था. In the circuit shown, the threshold voltage of each NMOS transistor is 0.6 volt. Ignoring the effect of channel length modulation, body bias, the value of Vout 1 and Vout 2. This is the Vout 1. And Vout 2. This is the Vout 2. You have to find the value of the Vout 1 and Vout 2. Only threshold voltage is given, that is the 0.6 volt. Redraw the diagram. Where simply redraw the diagram and you will get the answer. Right. This is the drain terminal. Right. What is asked here? V out 1. So this is the drain terminal. This is the MOSFET 1. This is the MOSFET 2. So drain terminal of 2, gate of 1, source of 2. It is connected to gate. And this is the drain of 2, and this is the source of 2, source terminal, source of 2. Now connect. This is the standard diagram. This is given as 3 volt. Both are connected. This is 3 volt, that is 3 volt, and this is connected here, and that is the actual diagram is this one. Here we want V out. Here we want V out. Now, what is the threshold voltage here? 0.6 volt. What is the threshold voltage here? 0.6 volt. Write down the KCL from this point to this point. What is the V out? What is the highest voltage across the capacitor? 3 minus 0.6 minus 0.6. You will get 1.8 volt. That is the highest value. 1.8 volt. This is the highest voltage across the capacitor. Already we have solved one question, that is on sampling. This is another type. So 3 minus 0.6 minus 0.6. So please redraw the diagram. This is the drain, that is the drain D1. This is the D1. Oh, sorry. This is D1. This is D1. Because I am considering it M1. So D1, D1. This is the D2, G2. This is D2. This is S2. This is the case. That is the connection. That is the connection of the diagram. Next one. Now, what about this diagram? This is the drain, source connected to the drain, source connected to the drain, source. So this is another type of connection. Source is connected to the drain. Source is connected to the drain. They all are connected in what series? Then here we are giving the 3 volt. Okay. This is capacitor is connected at the end. This is 3 volt. This is 3 volt. This is 3 volt. It will allow the current, same current will pass through this, same current will pass through this. What is the maximum voltage? This is 0.6 volt. To directly apply the KCL here, this one, KVL. When I am applying the KVL here, 3 minus 0.6, what is the highest value? 2.4 volt. .4 This is the 2.4 volt. ओके तो ये है एकदम सिंपल सा क्वेश्चन. देखो ऐसा क्वेश्चन बार बार आएगा तो आपको ध्यान रखना है. पहले कुछ भी समझ नहीं आया तो फिर से रीड्रॉ करो डायग्राम एंड देन फाइंड द वैल्यू. तो सिंपली ड्रॉ द डायग्राम एंड देन गेट द आंसर. दिस इज अबाउट दिस डायग्राम 1 and 2. तो आंसर इज 1.8 and 2.4. Okay, Zener diode voltage regulator. What is the answer? In 2019, again in 20, again in 2022. But that question is we have to solve. We have to find the minimum and maximum value of the input voltage. How we are going to find the minimum and maximum value of the input voltage? So that is the case. So that 4 options are given here. So when the 4 options are given, then if, first of all, in the circuit shown, the breakdown voltage and maximum current of the Zener diode are 20 volt and 60 milliampere. Means this time IZ max is given. We can't flow the current more than 60 milliampere. And second, VZ is given as 20 volt. VZ is given as 20 volt. Okay. When VZ is given as 20 volt means Zener diode should be in breakdown region, and that's why that is not the answer. And that will not be the answer, right? So both, matlab out of 2 we have to choose. You can take the calculated risk. Suppose we have limited time, then you can put B or C, then 50% probability. Why this is not the answer? Because 18 volt, if suppose we are giving the 18 volt, R1 is connected, RL is connected, definitely the voltage will be less than what, 20. Zener diode will be not in breakdown. It should be in breakdown region. It should be in breakdown region, will maintain the Zener diode in on state. What is the meaning of the on state? Zener diode should be in breakdown region. Second thing, suppose I am choosing the 20 volt. 20 volt is the margin. When we are giving the 20, definitely it will divide between R1 and RL. Again, we are going to get what, less than what, 20 volt across the Zener diode. That's why Zener diode will be not in breakdown region. Now, out of these 2 we have to choose. Then simply, in the circuit shown, the breakdown voltage maximum current of the Zener diode is given R1 200 ohm, RL 1 kilo ohm. What is the range of the VI that will maintain the Zener diode in on state? Always remember, again, only 2 formula. IZ, last class already I have given. IZ minimum. This is the current I, this is the current IZ, this is the current what, IL. So what is the IZ is equal to I minus IL. What is the IZ minimum? I minimum minus IL maximum. It should be greater than or equal to what, IZK. It should be greater than knee current. If the knee current is given here, no. If the knee current is not given, 0. Simply, minimum means VI minimum minus VZ upon R1. VI minimum minus VZ, voltage across this point is VZ because it is in breakdown region. VI minus VZ upon R1. What is the IL maximum? This voltage is under regulation. This voltage is V0. V0 is equal to VZ because that Zener diode is in breakdown region. Always remember, for full range of VI and for full range of RL, Zener diode should be in breakdown region. That is called on state. So V naught means Vz. So what is the current? V naught, that is nothing but Vz upon RL minimum. But the fixed value of RL is given to IZK. That is the standard formula. So V naught is equal to Vz. Now you have to find the Vi minimum. Vz is 20 volt. R1 200 ohm means 0.2 kilo ohm. 200 ohm means 0.2 kilo ohm minus V naught is Vz 20. RL is not variable. If it is variable, then you have to choose the minimum value. But the RL is fixed at 1 kilo ohm. You can choose 1 kilo ohm. It should be greater than or equal to 0. IZK is not given minimum current, then you can take it 0. What is the answer? Then Vi minimum minus 20 is equal to, this will become 20 into 0.2. And this is Vi minimum is equal to 20 plus 4, that is 24 volt. 24 volt is the minimum value of the Vi for which Zener diode will remain in on state. That is the condition, 24 volt. Which answer 24 volt? Out of what? B and C. B and C, finished. No need to calculate the second value. And that is the use of what? MCQs. That is the use of MCQs. Bharat Raj, how are you? Very good evening. Okay, हो गया ना 10 से 15 सेकंड में सॉल्व. ना बताइए व्हाट इज द व्हाट, अगर मान लो मैक्सिमम कैलकुलेट करना है, देन व्हाट इज द मैक्सिमम वैल्यू? ऑलरेडी यू हैव द आंसर 36 वोल्ट. Now, okay, this is the case. Second one. For maximum, what is the maximum value भाई? अरे आप लोग जवाब क्यों नहीं दे रहे हो? भरत, गुड इवनिंग, मुरली एंड अदर स्टूडेंट, प्लीज गिव मी द आंसर. भाई आप अपनी रफ कॉपी पेन, प्लीज यूज योर रफ कॉपी पेन, वर्चुअल कैलकुलेटर एंड ट्राई टू सॉल्व दिस क्वेश्चन. Already solved, and second time, third time, no problem. These all are authentic question, previous year questions. Now, how we are going to find the IZ maximum? Every time when we are solving, we are getting some new concept because it is a standard diagram. So IZ maximum means what? I maximum minus IL minimum. When I am writing this, this is a very simple concept. IZ is I minus IL. When I went maximum, this should be maximum and that should be minimum, then the difference will be maximum. Difference will be maximum. I maximum. I maximum means you have to choose the maximum value of Vi, and voltage at this point is fixed Vz. Vi max minus Vz upon R1. IL maximum means what is the output? Vz upon RL maximum. This current should be less than IZ rated. IZ rated, that is given. What is the maximum current through the Zener diode? You have to give the value of Vi max minus Vz. What is the Vz? Vz is 20 volt. R1 0.2 kilo ohm. Vz 20, RL 1 kilo ohm. It is fixed. It should be less than or equal to 60 milliampere. What is the 60? That is the rated current given in the question. The maximum current of the Zener diode are what? 60 milliampere. That is called rated current. It should be less than that. So what is the Vi maximum? Vi maximum minus 20 upon 0.2. It will become 80. It should be less than or equal to 80. 0.2 multiplied to Vi maximum should be less than or equal to 80 into 0.2 plus 20. This is nothing but 16 plus 20, 36 volt. 36 volt is the answer for this question. 36 volt is the, so which answer is correct? 36 volt. This is the case. Okay, right. Now in this case already I have given no doubt that because it's MCQ, what is the best answer? C. But it is not the worst condition. Worst condition means what? Worst condition means Suppose that is the diagram. Again, I am getting worst condition means this is the formula. Okay, that is the formula for the maximum current through the Zener diode. If what is the meaning of the RL maximum here? No doubt in this question RL is not removable. 1 kilo ohm we are considering, but RL maximum means suppose one will remove the RL. Simply remove the RL. Then tell me what will happen. If suppose I am removing the RL. Now this portion is act as open circuit. When I am removing the RL, this is called worst condition. When RL become infinite. When RL become what? Infinite. Once the RL will become infinite, the IL minimum, what is the IL minimum? IL minimum will become what? 0. Then the complete current will pass through the Zener diode. That may be the case. In numerical answer type question or in other question, you can choose that. But in that case, what is the VI maximum? VI maximum minus 20 upon R1 0.2. This will become minimum current will become 0. This should be less than rated current. What is the rated current? 60 milliampere. Then VI maximum minus 20 is equal to 60 into 0.2. That is nothing but 12. What is the VI maximum? 20 plus 12, that is the 32 volt. 20 plus 12, that is the 32 volt in that case. But it is MSQ. You have to consider, right? 32 again, 34 is greater, and this will not, 22 is not satisfied. And that's why the answer is what? C. Means, answer C means it is non-removable. Non-removable. This is a non-removable source. Okay. 1 minute. Next question. Okay. This is a question on what? Current mirror circuit. Question on current mirror circuit. Again, standard circuit, 2 marks question. New student, third year student, please watch this. That similar type of questions we are getting. Already I have taken one session. You watched that session? 45 marks in 45 days. Right? 45 marks in what? 45 days from the technical paper, and around 15 to 20 marks from math and aptitude. Now you are going to get the good rank in what? GATE exam. So how? Simply try to solve the previous year question with us. We will give you the idea which topics are important. This is the question, how we are going to solve this particular question. Same type of question. Zener diode, amplifiers, voltage regulator, and current mirror circuit, biasing of the BJT, biasing of the MOSFET, operational amplifier, integrator, band pass filter, low pass filter, high pass filter. These all are the important topics. Now tell me, what is the answer for this one? This is the question on current mirror circuit. तो एक बार जरा भाई आप एक बार इसे फिर से आप लोग लाइक कर लीजिएगा सेशन को. लाइक तो आपने, अगर आपको लग रहा है कि ये शानदार तरीके से चल रहा है, आपको बात समझ में आ रही है, तो लाइक कर लीजिए. अब देखते हैं इसे. देखो ये आता है करंट मिरर सर्किट. थोड़ा जूम करोगे तो आपको अच्छे से दिखाई देगा. ये हो गया जूमिंग. नाउ वॉच दिस. इसका तो पूरा स्ट्रक्चर बिगड़ जाएगा. रुक जाएंगे 1 मिनट. ओके, यहां देखिए. This is the current mirror circuit, right? So what is the standard diagram for the current mirror circuit, new student? These two are connected. Remember, for both VGS, these are connected in parallel. Therefore, VGS2 and VGS1 are same. Here it is connected. This is the current mirror. But since the current is directly proportional to what? Aspect ratio, WL/3. This is the WL/2. WL, मान लेते WL1. This is 2. So what will be the current here? If the current at this node, we have idea, the current in that branch will become I0 by I1 is equal to W by L of 2 upon W by L of 1, because current is directly proportional to aspect ratio. So that is the case, right? So WL1 by WL2, you can find the current at this point. Simple. So this is that. If this is the connection, they will form a mirror image, and that is the relation between the current. Now in this diagram, this current is, it is 1 milliampere. What is the current through the gate terminal? 0. This is 1 milliampere. This is in saturation. When the drain is connected to the gate, that will be in saturation. This is also in saturation. We are having the same VGS here, same VGS here. 1 milliampere, WL by is 3, WL by 2. So what is the current here? Let IX. IX will become WL by, this is the 3, what is it's 2 into what? 1 milliampere. It will become 1.5 milliampere. Okay, this is the 1.5 milliampere. At this point, it is a 1.5 milliampere. Now, watch this. What is the value of V1 given in the question? V1 is given as 0 and V2 as VDD. V1 0 means at this point voltage is given as 0. If this is given as 0, then what about this MOSFET? This is off. If this MOSFET is off, what is the current here? 0. This current will become 0. So what about the IX? IX is coming from this point. IX is coming from this point. Now this too will make current mirror, right? But it is a PMOS, P channel MOS. Okay, no problem. Now this I out, in case of PMOS, again we are having the current mirror circuit like this. This is the case, or this is the I out. If it is I reference here, then this is the I out. Then I out is equal to I reference. Okay, so that will be the case. Then tell me, what is the case now? This current, this one is what? 0. IX, same IX. So what is the relation between the IX and I out? I out is equal to 40 divided by 10 of what? IX. That is 4 times of IX. So what is the 4 into 1.5? This will become 6 milliampere. 6 milliampere is the answer for this question. Very simple. V2 is given as VDD, and that's why this is on, but this is off. VDD and E. This is the simple case. 6 milliampere. Next question. So last year again, we are getting the question from this current mirror circuit. Next one. Now, it is in electrical engineering in 2019. What is the question? VGS is the gate to source voltage, VDS is the drain to source voltage, VTH is the threshold voltage of enhancement type MOSFET, the condition for the transistor to be biased in saturation. Here for saturation, it should not be in cutoff. So VGS should be greater than what? VTH, and VDS should be greater than or equal to what? VGS minus VTH. That is the condition. Which condition is right? VGS should be greater than this one. C is the option. VGS should be greater than VTH and VDS should be greater than or equal to VGS minus VTH. That is the condition for saturation. 1 mark question. 1 mark question. V1 is equal to Y of V1 is equal to 0 is given, na? V1 is given 0. That is the. So if suppose in a particular MOSFET, if this is given as 0, so what about this is in cutoff? It is not getting the sufficient voltage, so that this will remain in cutoff region. this will remain in cutoff region. Okay. Second thing, since it is in saturation, means the voltage at this point is positive. If the voltage at this point is 0, voltage at this point is positive, definitely this drop is positive VDS. If the VDS is positive, 0 minus VDS, then the VGS of this diagram will become what? Negative. If the negative means definitely it is in cutoff. Murli, now it is clear? V1 is 0. And at this point we are having the positive voltage. So what is the value of the VGS? Negative. Negative means definitely this is in cutoff. Definitely this transistor is in what? Cutoff. Okay. VGS not greater than, it is less than 0. Negative ho gaya to negative. This is V1 is actually because of that 0 value and because of this VDD. For example, it is VDD is given. Try to understand this concept. If this is the VDD is given, my dear, there will be the drop across a drop of what? For example, VTH, and VDD is 5 volt. 5 minus 1. So what is the voltage at this point? 4 volt. 0 minus 4. So what is the voltage at this point? Minus 4 volt. Definitely it is in cutoff. Definitely it is in cutoff. Okay. In this way we can find the value. Now, MOSFET, very simple in electrical engineering. Please watch this question, formula based question electrical. This means if suppose we are going to get 6 marks from analog, okay, no problem, only 6 marks from analog, but we can get 6 out of 6. Are you getting my point? Electrical and instrumentation branch, you can fetch 6 out of 6. तो आप गारंटी लेते हो क्या? मशीन के पूरे क्वेश्चन बना लोगे, पावर इलेक्ट्रॉनिक्स के पूरे क्वेश्चन बना लोगे, पावर सिस्टम के पूरे 100% क्वेश्चन बना लोगे? कोई गारंटी नहीं है. लेकिन बिकॉज दोज आर कोर सब्जेक्ट, बट एनालॉग, डिजिटल, कंट्रोल, नेटवर्क, right, it will help you. If suppose you want to get the rank, then my dear, 100% from analog, 100% from control, 100% from digital, little effort, more result. Okay, so this is a simple formula based question. Now, always remember, when the drain is connected to gate, it is in saturation region, W by L is given, and when it is connected, this is the VGS. S is connected to ground, so VGS is nothing but V0, because the voltage at this point is V0. VG equal to V0, Vs is 0, so VGS will become V0. You have to calculate ignore the channel length modulation, Vt is given, you have to calculate the V out. Current is given 5 microampere, no problem. It is in saturation, so what is the formula? IDS is equal to half of K and S W by L VGS minus VT the whole square. Okay, remember VGS is equal to VGS is equal to what? VG minus Vs, that is VD minus Vs. Why VD minus Vs? Because VD is connected to this. Means VD is equal to VG, means VDS is equal to what? VGS. 100% sure VDS is greater than what? VGS minus VT, and that's why it is in saturation region. Now it is in saturation region, so that is what is the VD? V0 minus 0, it will become V0. What is the IDS given? 5 microampere. This is given as 5 microampere. 1 by 2. What is the K and S? Mu and CUX. 100 microampere it is given. So no need to change the unit. 100, 5 micro. W by L, 10 by 1, 10. No need to change the unit. V0 minus VT. What is the VT? 500 millivolt. Matlab means 0.5 volt square. Right? This is the 5 cancel out. It will become 1 by 100. Root over this is equal to V0 minus 0.5. 1 by 100 is what? 0.01. 1 by 10. 1 by 10 is 0.1. 0.1 is equal to V naught minus 0.5. It will become what? 0.6 volt. 0.6 volt is equal to what? 600 millivolt. 6 volt. 600 millivolt. Okay, so that is the answer for this particular question, directly formula based. Next one. Now that is the question on operational amplifier. Already in previous class I have given you the standard formula. It is nothing but a differential amplifier. In the circuit below, the operational amplifier is ideal. If V1 is 10 millivolt, V2 is 50 millivolt, the output voltage is. Always we have to check this ratio. RF, R1, R3, R2. First of all, check this ratio. RF by R1, that is equal to what? 100 by 10. Or this is equal to what? R3 by R2. Because it is also 100 by 10. This ratio is satisfied. If the ratio is satisfied means what? Common mode gain is 0. CMRR is infinite. And the output will become ADVD. And where AD is nothing but RF by R1, or VD will become non-inverting terminal voltage. Non-inverting terminal voltage is V2 minus inverting terminal voltage. That is the standard formula. That is the standard formula. So what is the RF? 100. What is the R1? 10. What is the V2? V2 is given as 50 minus what is the V1? V1 is given as 10. 10 into 40. So what is the answer? 400 millivolt. 400 millivolt directly. Direct use the formula. First of all, check this. If this condition is satisfied, directly you can say 400 millivolt. No need to write the complete formula for this diagram. Okay. Very simple. Or if you want the standard, so yesterday I have given the answer. Yesterday I have given V out is equal to 1 plus RF by R1. This is RF, this is R1. If ratio is not satisfied in that case, into R3 by R2 plus R3 into V2. This is the non-inverting terminal voltage. Minus RF by R1 into what? Inverting terminal voltage, V1. Again you will get the same answer. Again you will get the same answer. But if this ratio is satisfied, directly apply this formula. Directly apply this formula and you can save the time. And they will ask what is the CMRR infinite, what is the AC 0. This is the ideal differential amplifier. Now that is a question from the instrumentation branch. Now we will solve 1 or 2 questions from instrumentation branch. बहुत सारे इंस्ट्रूमेंटेशन ब्रांच वाले बच्चे भी इंतजार कर रहे हैं. लेकिन एक बात बताएं, चाहे इंस्ट्रूमेंटेशन वाले इंस्ट्रूमेंटेशन तो सॉल्व करेंगे, लेकिन वो इलेक्ट्रॉनिक्स और इलेक्ट्रिकल के क्वेश्चन दे विल सॉल्व, राइट. फर्स्ट ऑफ ऑल यू हैव टू कवर question from instrumentation branch, then you will go for what? Electronics and electrical. Please watch the session so that you will get the idea. In electronics and electrical student, what is the answer? No. In the figure A and B shown below, the transformer are identical. Both the transformer are identical, except that the transformer in figure B is center tapped. Assuming the ideal diodes, the ratio of the root mean square voltage across the resistor in the figure A and B. Okay. So this is what, this is a full wave rectifier. This is what? Full wave rectifier. And this is a nothing. It is a simple, we are giving the input, we are getting the step down or step up output. Step down or step up output. So what is the figure? For example, in first figure, this is the Vm. Let the turn ratio is N1 is to N2. So this is the, what is the input? V0. So Vm by V0 is equal to N2 by N1. N2 by N1. Now we are getting the output. Simply again we are having the sinusoidal signal. Let this, the peak value is what? Vm. Peak value is Vm, 0 minus Vm. So what is the RMS value? Vm by root 2. This is the RMS value from the first circuit. From this first circuit, this is the step down. After step down, we are getting the output across this. Voltage across this. This is the voltage. Vm we can find N2 by N1 into V0. What is the V0? This is the peak value of this signal. Step down and then you can get the value. And what is the RMS value? Vm by root 2. Okay. From the second diagram, my dear. Second diagram. In the second diagram, it is center tapped transformer. If it is center tapped transformer, then what will be the turn ratio? Here it is the same transformer, it is center tapped. So what will be the turn ratio? If it is N2, then it will become N2 by 2. This will become N2 by 2. So what is the voltage at this point? And voltage at this end, it will become Vm by 2. Pass. So voltage at the transformer end, as compared to this, if it is Vm, then it will become Vm by 2, Vm by 2. Just half, Vm by 2, Vm by 2. And this is a center tapped transformer type full wave rectifier. So you are going to get this type of waveform, full wave. But what is the peak value? What is the peak value? Vm by 2, not Vm. Vm by 2. Peak value is Vm by 2 because of center tapping. Now, what is the RMS value of the full wave rectifier? Peak upon root 2. No doubt. RMS value is again peak of the output upon root 2. But what is the peak? Vm by 2. So it will become Vm upon 2 root 2. So RMS value of this, when we are comparing, we are choosing one output Vm, here it will become Vm by 2, and that's why this is the Vm by 2 root 2. Now we are having both the outputs. In one case, in first case, it is the Vm by 2, Vm by root 2. In second case, it is the Vm by 2 root 2. Divide these two. It will become 2:1. It will become 2:1. First one is 2 times of second one. That is the case. The ratio of the root mean square voltage in figure A and in figure B. So this is the 2:1 ratio. 2:1. So ये है center tapping. Remember this one. Next one. तो हो गया ये सॉल्व 2:1. Now again in instrumentation branch, very simple diagram based question. In the circuit shown below, the input voltage Vin is positive. Please tell me what is the name of this diagram? Logarithmic amplifier or anti-logarithmic amplifier? The current I, voltage V, characteristics of the diode can be assumed to be I naught e raised to power V by Vt. Under the forward bias condition, where Vt is the thermal voltage, I naught is the reverse saturation current, assuming an ideal op-amp, the output voltage V out of the circuit is proportional to. Output voltage V out is proportional to. My dear, it is a anti-logarithmic amplifier. Anti-logarithmic, right? Amplifier. अब ये एंटी लॉगरिथमिक एम्पलीफायर मीन्स ई रेज टू पावर. ई रेज टू पावर, विच आंसर इज ई रेज टू पावर? सी. Directly you can say that is the answer is what? C. Or otherwise you can solve what is the current. The same current will pass here. Let this is R, proportional to, no, it is asked. And this is the diode. What is the drop across the diode? V in. Then this is the, because of virtual short, this is 0, this is 0. So what is the drop across the diode? V in. The same current will pass. So we can write IF is equal to I. What is the IF? 0 minus V out upon RF. 0 minus V out upon RF. This is the RF resistor. What is the I? What is the current through the diode? It is given by I naught e raised to power V in by V. T. V in by Vt. So what will be the V out will become V out will become minus I naught into RF e raised to power V in by Vt. Eta is taken as 1. I am taking ideality factor 1. Means V out is proportional to out. E raised to power V in by Vt. That is the answer. Anti-logarithmic amplifier. Anti-logarithmic amplifier. Eta is taken as 1 here. It is given here. Okay. That is the current through the diode. I have taken this. What is the current through the diode? I naught e raised to power V in by Vt. I naught is the reverse saturation current. Now, in instrumentation branch, correct biasing condition for typical operation of light emitting diode, photodiodes, Zener diodes. Light emitting diode, forward bias or reverse bias? Then again we will solve one question on light emitting diode. Light emitting diode is what? Forward bias. Light emitting diode, it works when the diode is what? Forward bias. When we are passing the current in this direction, then it will give the radiation, light output. It is forward bias. Second is photodiodes. Photodiodes means when we are giving the light, the conductivity will increase. And this is the reverse bias. Photodiode, we are using the optical lens, we are focusing the light here. This is when the diode is reverse bias. Third one is Zener diode, reverse bias. Zener diode, we are making it what? Reverse bias. So answer is A, forward bias, reverse bias. Okay, answer बिल्कुल सही है. विश्वनाथ मुरली, भरत, Raj, your answer is correct. But here, what about the other student? How many students from the third year? No one from the third year, final year. यार ये तो बड़ा चाम होता है ना थर्ड ईयर में रैंक लाना. थर्ड ईयर में अगर रैंक ले आया तब तो फिर क्या बात ही क्या है आपकी, हो गया आपकी लाइफ सेटल्ड. खैर लाइफ तो क्या सेटल्ड होती है, सब जिंदगी भर चलते ही रहता है, जद्दोजहद है ना. जिस दिन आप सेटल्ड हो गए, जिस दिन आप रुक गए, तो रुके हुए पानी से क्या आती, बदबू आती है. यस और नो? तो अगर आपको रुकना नहीं है बस, लेकिन जब आप एक लेवल पे जंप कर जाते हो विद दिस गेट एग्जाम, तो वहां से आगे की जर्नी बड़ी स्मूथ होती है. रिमेंबर दैट पॉइंट. व्हाट अबाउट द फर्स्ट प्लेटफॉर्म? If you are going to start from this one, it will become very difficult. If you are going to start from your journey from this point, then definitely it will help. तो initially we want good platform. तो ये है गेट एग्जाम. अगर आप निकालते हो तो बहुत बढ़िया, नहीं भी निकालेंगे तो क्या हो जाएगा वैसे, अगर मान लो नहीं निकले तो क्या होगा, नथिंग, है ना. ऐसा सोच कर देने जाइए. निकल गया तो बहुत बढ़िया, नहीं निकला तो उससे भी बढ़िया. तो विदाउट टेंशन जब आप देने जाते हो ना, तो आप अपना नेचुरल तरीके से बनाते हो, और जब नेचुरल तरीके से बनाते हो ना, क्वेश्चन ज्यादा बनते हैं. ओके. अंडर प्रेशर कई बार क्या होता है, आप गलत कर देते हो, सिली मिस्टेक्स कर देते हो, कॉन्सेप्ट भूल जाते हो. तो आप ये सोचो कि गेट लगा के क्या कर लेंगे हम, सोचना है ना, लगाना तो है हमें. बस थिंक अबाउट दैट कि क्या होगा रिजल्ट हमारा, छोड़ो मारो गोली. राइट. उसके बाद बिना डरे बनाओ क्वेश्चन, कोई फियर नहीं है, कोई एग्जाम देने का कोई डर नहीं है. फिर देखिए कैसे परफॉर्मेंस आती है. राइट. और मिनिमम 10 to 12 आवर्स लग जाओ बस. अभी एक महीने की बात है. ठीक है. तो अब देखते हैं जरा. अभी तो कई लोग सोच रहे होंगे सर कोविड का रिजल्ट आ रहा है, कहीं एग्जाम पोस्टपोन तो नहीं होगा. अरे भाई वो सब छोड़ दो, अभी फोकस करो पढ़ाई पर. तो दैट इज द क्वेश्चन. ए इज द आंसर. नेक्स्ट वन. नाउ फॉर स्ट्रेंगर in a Wheatstone bridge, again this type of question in what? Instrumentation branch, but they may ask in electronics or in electrical branch, because measurement it is in syllabus of electrical branch. Strain gauge in a Wheatstone bridge, this is the Wheatstone bridge, R plus del R, R minus del R, R minus del R, R plus del R are connected to an instrumentation amplifier. Instrumentation amplifier means differential amplifier. From the choices given below, the preferred value for the common mode rejection ratio of the amplifier. What should be the value of CMRR? What is the ideal value of the CMRR? Forward bias in LED, yes. Forward bias in है, तो मैंने reverse bias बोल दिया क्या? तो LED is the forward bias, yes. Forward bias, LED forward bias, photodiode reverse bias, Zener diode reverse bias. So A option. So why Chinmay? You are asking or you are informing me? Right, you are asking. LED works when the diode is forward bias. Okay. Photodiode, pin diode, reverse bias. Solar cell, it is in what? Reverse bias, in a fourth quadrant. Okay. That is the case. Now, what should be the CMRR? CMRR should be infinite, or it should be as high as possible. So in a dB again it should be high. So which one is the high? So that is what is asked here. From the choices given below, the preferred value for the common mode rejection ratio, it should be as high as possible. Which one is the highest? This is the highest value, D. So D is the answer. 1 mark question, ideal condition, as large as possible. 100 is the highest value. It is asked in dB. So remember, in a dB it is what? CMRR. In a dB it is given by 20 log base to 10 mod of AD by AC. Ideally AC should be equal to 0. So what is the CMRR? Infinite. It should be as large as possible. Okay, so D is the option. Next. Now, that is the question in, again, current mirror circuit instrumentation branch in 2019. One question in instrumentation branch. So what is the answer? Very, very simple one. In the circuit shown below, all the transistors are N-channel enhancement mode MOSFET. They are identical and are biased to operate in saturation mode. All are in saturation mode. Already I have given, when we are making current mirror circuit or this type of circuit, all transistors are in saturation mode. Ignoring the channel length modulation means lambda is equal to 0. The output voltage Vout is. Output voltage Vout is 1 milliampere current is given. W by L is not given, means all are identical. Written all are identical means aspect ratio for all the transistors are same. So if it is same, then how we are going to solve this? Very simple one. Remember, this is the current mirror, 1 milliampere current here. Same current will pass here 1 milliampere. Okay, no issue. 1 milliampere here, same current 1 milliampere here. What is the current through the gate terminal? 0. Therefore, this is also 1 milliampere. Now, the voltage at this point are equal, and that's why we are having the same current. These two are connected in series. For example, this is the MOSFET 1, this is 2, this is 3, this is 4. Now, if this is I3, then this is I4. I3 and I4 are equal because they are connected in series. What is the current here? 1 milliampere. This will pass through this transistor only. Because in the gate terminal, what is the current? 0. Now, we want Vout. Then what is the voltage at this point? Let this is the VGS3. It is the VGS4. Now, the current is same, characteristics are same, everything is same. Therefore, VGS4 and VGS3 are equal. VGS3 is equal to VGS4. And what is the Vout? Why we are calculating the VGS3? Because Vout, the voltage at this point is 6 volt. When we are subtracting the VGS3 from the 6 volt, you will get the Vout. Vout is nothing but 6 minus VGS3. 6 minus VGS3. Now tell me, what is the VGS4? Write proper KVL. You have to write the proper KVL from this point to this point. Right? The proper KVL, I will get the idea. What is the answer here? This is the 6 is equal to 1 into 4 plus VGS4. 1 into 4 plus VGS4. So what is the VGS4? It will become 6 minus 4, that is nothing but 2 volt. So if it is 2 volt, what is the voltage? 2 volt. So 6 minus 2, what is the V out? Six minus 4, that is nothing. 6 minus 2, 4 volt. 4 volt is the answer for this question. 4 volt is the answer for this question. Yes, Chinmay Bharti, your answer is correct. ये simple सा diagram. Write down the proper KVL, KCL. 1 milliampere, 1 milliampere. Always remember current through the gate terminal will be 0. So this current will pass through 1 milliampere. These two are connected in series. Characteristics are similar. Everything is similar. All are in saturation, and that's why the gate to source voltage in series connection, these are same. These are same. Right? Okay then. Next one. Next. Now this is a question on operational amplifier. Now two or three more question, right? So then what is the another one? In the circuit shown below, all operational amplifier are ideal. All are ideal. The current I is equal to 0. This current I is equal to 0. When the resistance R is equal to, what is the value of this resistor? Here current is 0. This is the, we can write the KCL at this point. But to write the KCL at this point, then we will get the relation I. So what is the voltage at this point? Virtual ground, because there is a negative feedback. This voltage is 0. It is nothing but inverting operational amplifier. Are you getting my point? This is the inverting operational amplifier. If the voltage at this point is Vx, so what is the voltage at this point? Minus Rf by R1 into Vx. Rf or R1 to 3, it will become minus Vx. So at this point the voltage is minus Vx. What is the value of the V0? V0 will become minus 12 by 3 into V01. So V01 is minus Vx. So minus it will become plus. It will become 4 Vx. The voltage at this point is 4 Vx. So this is a non-inverting operational amplifier. That is the non-inverting operational amplifier. Directly you will get the 4 Vx. Now you have the voltage at this point Vx. Voltage at this point 0, voltage at this point 4 Vx, and current here. Then you can write the KCL at this point. This current should be equal to 0. You can write the KCL at this point. So what is the incoming current? I. So what is the incoming current? The voltage at this point is Vx. Voltage at this point is 4 Vx. Right? And voltage at this point is minus Vx. Now write down the KCL. What is the incoming current? I. What is the outgoing current? Vx minus 0 by 3. Because this terminal is 0. Plus Vx minus 4 Vx. Vx minus 4 Vx by R. This should be equal to 0. This should be equal to 0. So you can write Vx by 3 minus 3 Vx by R is equal to 0. So Vx, you can take Vx as a common. Vx will become 0. 1 by 3 minus 3 by R is equal to 0. 1 by 3 is equal to 3 by R. So what is the R is equal to? Here 3 into 3, 9 kilo ohm. What is the value of R? 9 kilo ohm. This point is clear? So sometimes I am writing 1 step, 2 step, 3 step, then finally 4 step. Oh, this is my experience, my dear students. We are applying the right concept. Everything is correct. But sometimes what happen, I don't know. This is R is equal to 3 by 3, that is 1. How? Not clear. That is called what? Silly mistake. Just because of what? Ignorance. Careless हो गया यहाँ पे. 1 by 3 is equal to 3 by R. R is equal to, and we are doing something extra, and that is 3 by 3. We are getting 1. That is the wrong answer. Be careful about this type of mistake. होता है कि नहीं होता? Yes or no? कि मुझसे ही होता है भाई. मुझसे तो बहुत होता है. थोड़ा सा भी इधर उधर ध्यान गया तो मेरा तो गया, पूरा आंसर गया. Calculation mistake. That is the calculation mistake. So this is a 9 kilo ohm is the answer for this question. To apply the non-inverting operational amplifier, inverting op-amp directly gate, or you can apply the KCL at this point or KCL at this point. Then you can find the voltage at this point, and once you will get, that is an easy method. Now, last two question, a very simple one. Two identical NMOS transistor, again this is the gate 2018 in EC branch. Two identical NMOS transistor M1 and M2 are connected as shown below. The circuit is used as an amplifier with the input connected between gate and source. Where is the input? ये देखो, ये है gate, this is the source. This is the gate, that is the source. Here we are connecting the input and output taken between drain and source. Output is taken between drain and source. This is the output. Terminal, this is, we are applying the bias here, DC bias, and VD are so adjusted that both the transistors are in saturation. The value is not given, but both the transistors are in saturation. The transconductance of the combination is defined as GM. Transconductance of combination is defined as GM, dID by dVGS, while the output resistance is the drain of M2. Output resistance is drain of output, means here we have to calculate the output resistance R0. Overall R0, drain of the M2. We have to calculate the output with respect to drain and with respect to ground. That is the meaning of this word. You have to find the output resistance from drain to what? Up to ground. Right? Then let GM1, GM2 be the transconductance and R01 and R02 be the output resistance of the transistor. Which of the following statements about the estimates for GM and R0 is correct? Overall GM. This is given as nearly equal to. Now all are nearly equal to. All are nearly equal to. Now my dear, it is a standard circuit. When we are giving the input to the gate and when we are taking the output, this is nothing but cascade amplifier. What is the name of this circuit? Cascade amplifier. Where common source is followed by common gate. This terminal is common. Common source, this is followed by common gate. Right? But we will solve this question. And remember, the overall transconductance is nothing but GM1. This is the direct answer for cascade amplifier. But how we can find the output resistance for this? So I will draw the simple small signal model and you will get the idea about that. Okay, what is the model here? Right. Now, in the model, it is a cascade amplifier. Already I have written this is the GM is equal to nearly equal to GM1. Right, this is the one. First one. This is the second one. Now, how the cascade? Here we are giving the input to the gate. We are taking the output from the source. Right? Input to the gate, output from the source. So this is, that's why it is a common drain. Input to the gate, output to the drain, and that's why it is called common source. Input to the drain, output from the input to the source, output from the drain. That's why it is a common gate. Common source followed by common gate, that is called cascade amplifier. And for this, standard answer is what? GM is equal to GM1. Now, what is the small signal model? When a small signal model is required, simply this is the small signal model. You can directly draw GM2, VGS2, R02. This is the drain D2. This is the source S2. This is the gate G2. Now, its source S2 is connected to drain of this. So again we will draw GM1, VGS1, R01, right? And that is the source is connected to what? Ground. This source is connected to what? Ground. Here we are having G1 With G1 we are connecting, this is the G1, we are connecting the input. Here the input is connected here with respect to ground, right? Then, and this its source, its drain, this drain is connected to source. This is the drain actually. Drain is connected to source. From D2 to ground we are taking the output. This is the ground. Here we are taking the output. Plus minus V0. That is the diagram. Okay. This is the diagram. GM VGS to R2. Now remember one thing. This is the plus minus. This is the VGS2. This point to this point. And what about the G2? G2. When we are doing that AC analysis, this is the AC analysis. So this VD will become 0. This will become 0. Right? This VD means this is the, no doubt it is biased. The VDD is not given. So already VDD will become 0 and this VS bias will become 0. So this source is connected to what? Ground. This source is, this gate is connected to ground. Here it is connected to input. So that is the complete diagram. Now, how we can find the output resistance? Okay, when it is asked what is the trans conductance of the overall, already I have given GM1, but you can find with this model. But remember, how we are going to find the output resistance? To find the output resistance, that is called Thevenin's resistance. So to find the Thevenin's resistance, always remember, it is the output resistance. You have choose 1 volt battery divided by I. 1 volt battery. Here I will connect a 1 volt battery. And that this is the current I. Now please, proper distribution of the current. And always remember, when we are calculating the RTH, all the input signals should be equal to 0. Make it 0. When I am making it 0, this gate terminal is connected to ground. This source is already connected to ground. So what is the value of VGS1? VGS1 is 0. And that's why this current source will act as open circuit. This current source will act as open circuit. You can remove this because VGS1 is 0. Always remember, to find the Thevenin's resistance, make the VI 0, it will become 0. What is the value of the VGS2? This is connected to ground. Now, to get the value of the VGS2, write a KVL from this point to this point to this point. Now, how we can write the KVL? First of all, what is the current here? This is the current I. So what is the current here? GM to VGS2. So what is the current here? I minus GM to VGS2. Now this current again add and this will become I. Now what is this current? It will act as open circuit. So same current will pass through this. Same current will pass through this. So when I am writing the KVL from this point to this point to this point, you will get the VGS2 in terms of what? I R01. So write down the KVL. 0 is equal to VGS2 plus I into R01. So what is the VGS2? It will become minus I into R01. R01, this one. Okay. Once it is R01, this is open circuit. This is open circuit. I am writing the KVL. So what will be I minus GM2 into VGS2? Now you can write I minus GM2 into VGS2 as I minus, it will become minus minus, it will become plus GM R01, GM R01 into I. Now write down the KVL from this point to this point. Write down the KVL. When you are writing the KVL, it will become minus 1 is equal to, no, sorry, minus 1. This is the minus 1. Then it will become I minus GM2 into VGS2 into R02. So already we have calculated. So it will become plus I plus GM R01 into I into what? R02. Already we have calculated this value. This is multiplied with the R02 plus I into R01. I into R01 is equal to 0. Now you have to calculate 1 by I. So this is the I naught into R101. This is the I. You can take common. When I am taking the, okay, first of all multiply it. This will become R02 GM R01 R02 into I plus I into R01 is equal to what? 1. Take now I common. What is the 1 by I? 1 by I will become R01. This is the actual value of what? Output resistance. R02. Right? And it is approximated value is 1. So what is the approximated value? Because the GM is the transconductance and R0 is a high value. And that's why we can neglect this. It will become nearly equal to GM. And which GM? GM2. Remember that. GM2. Because GM1 is already 0. R02. That is the answer. This is the output resistance. So GM is nearly equal to GM1 and R0 is nearly R01, GM2 into R02. That's why the C is the correct answer. C is the correct. To draw the model, use the concept of network. Why you are writing Chinmay 1 minus GM1 VGS2? Why 1 minus GM? Where is the GM1? 1 minus, where is the 1 minus? Achha, you are writing something now. Already I have changed now that. Already I have changed that value. No doubt. This is what? 1 minus I minus GM2 into VGS2. What is the VGS2? Already I have calculated the VGS2 here. Minus I R0. This VGS2 is replaced by what? Minus minus, it will become plus. And that's why I am using this. Directly I am using this. Yes, so that is all about this question. How to, again, Norton's, so on. Now, last 2 questions because now I have to take one session on. जल्दी से मैंने आपको जो शुरुआत में बताया था उसका आंसर बता दो इसका. In the circuit shown, the operational amplifier is ideal. General voltage of the diode is 2.5 volt. At the input, unit step voltage is applied. Also at t equal to 0, voltage across each of the capacitor is 0. Initially, all the capacitors are unenergized. The time t in millisecond at which the output voltage crosses the minus 10 volt. We have to find the time where that it will definitely, when we are giving the 1 volt, because of what 180 degree phase shift, output voltage will what? Negative. Definitely negative, but there are capacitor. Finally, the capacitor will charge and then the voltage will increase in negative direction, or we can say it will decrease in negative direction. Initially all are 0. Initially all are 0. So how we can solve this question? After how much time it will reach to minus 10 volt? First of all, remember, initially all the capacitor never allows sudden change of voltage. It does not allow sudden change of voltage except for impulse signal. Then initially it will act as short circuit, There is a virtual short concept. So what is the initial voltage? 0. Now, when we are giving the 1 volt, there will be the current in this direction. There will be the current in this direction. Oh, sorry, opposite direction. There will be the current in this direction. And that's why this capacitor will charge, it will become plus minus. This will charge, it will become plus minus. When this capacitor will charge, definitely the V out will decrease. Why? Because this voltage is 0. But when, because these two capacitors are same, Now after some time it will charge up to 2.5, it will charge up to 2.5. When both the capacitor charge up to 2.5, tell me what is the V out. This is the 2.5, this is the 2.5. V out will become minus 5 volt. And because this voltage is 0, virtual ground, this voltage is 0, 2.5, the constant current will pass through this. That's why there will be the linear charging of the capacitor. Constant current will pass through this capacitor, constant current will pass through this capacitor. And what is the value of the current? V in by R. V in is the 1 volt and R is what? 1 kilo ohm. That is nothing but 1 milliampere. This is the constant current will pass through this, and that's why there is a linear charging of the capacitor. Right. Second thing, that is the minus 5 volt. But once this capacitor reach up to what? 2.5 volt. What about the Zener diode? Zener diode will be breakdown. Once the Zener diode is breakdown, what is the Zener diode voltage? 2.5 volt. Once the Zener diode is breakdown, the voltage will become constant. When voltage across that will become constant, then this is gone. Now the Zener diode is breakdown. Once it is breakdown, what is the voltage across this capacitor? Constant 2.5 volt. This is 2.5 volt. And this is the V0 actually. And this point is ground, matlab 0. But what is the current? Current is the constant, 1 milliampere again will flow. What about this capacitor? This capacitor will charge. VC2 is now fixed. VC2 is now fixed, but VC1 will increase. VC1 will increase. So when VC1 will increase, tell me, what is the final voltage across the VC1? It is fixed at 2.5 volt. So when it is fixed at 2.5 volt, we want minus 10 volt. Here, to write down the KVL, to 0 is equal to VC1 plus VC2 plus V0. Right? Now, VC2 is fixed at 2.5 volt. V0 we want 10 volt. So what is the value of VC? This is equal to 0. So what is the value of VC1? It should charge up towards 7.5 volt. It should charge up towards 7.5 volt. So how much time is required to charge it up to 7.5 volt? That is the question. So what is the voltage? Q by C. What is the current? IT. This much time is required upon what? C. You have to find the time. So what is the time is equal to C into VC divided by what? I. What is the C here? 1 microfarad, 10 to the power minus 6. What is the VC here? What is required? 7.5. What is the I here? 1 milliampere. 1 into 10 to the power minus 3. 1 milliampere. Already we have calculated constant current. So this will become 7.5 into 10 raised to power minus 3. That is nothing but 7.5 millisecond. 7.5 millisecond is required to charge the capacitor up to 7.5 volt, and this is it will remain at 2.5 volt. It will remain at 2.5 volt, and that is the concept. अच्छा क्वेश्चन है ये, और अच्छे से बना लीजिएगा आप इसको. That is from Instrumentation Branch. Okay. So this is the Zener diode. No. Sorry, this is the question from Electronics Branch. This is the 7.5 millisecond it is required. Okay. Then one last question. This was the question. Yes, that is from Instrumentation Branch. What will be the answer? In the circuit below, light dependent resistor. This is the light dependent resistor here. LDR, light dependent resistor. Here LED will give the light. If what is here? If there is dark resistance means when there is no light. The LDR has the resistance of 5 kilo ohm under dark condition and 500 ohm under illuminated condition. ठीक, this is the dark LDR. So when the dark means when there is no light, resistance is what? 5 kilo ohm. When there is a light, resistance is only 500 ohm respectively. The LED is off at time t less than 0. LED is now off. When the LED is off, what is the voltage at this point? What is the resistor? 5 kilo ohm. So when LED is off 5 kilo ohm, so what is the resistor? What is the voltage at this point? According to voltage divide rule, 5 into 1 divided by 6, that is 5 by 6 less than 2 volt. Means negative terminal voltage is less than positive terminal voltage, and that's why output is high. When this output is high, this is high, it is a, we are not giving any trigger, both are 1 1. It is a what? S bar R bar latch, that's why we have to apply the negative trigger. But here it is high, there is no trigger, and that's why Q will remain at 0, Q bar at 1, transistor is off, therefore there is no current through this LED. No current through this LED, that is the initial condition. Now that's why the LED will not glow and resistance will remain same. Now exactly at t equal to 0 seconds, switch S1 is closed. This switch S1 is closed. When this switch S1 is closed, there will be the current through this switch and LED will glow only for 1 millisecond and then kept open thereafter. Assuming zero propagation delay in the device. The LED, what about the LED? What are the options? Options are the turns on when S1 is closed and remain on after S1 is opened. Turns on when S1 is closed, turns off after S1 is opened. Turns on when S1 is closed and toggles periodically from on to off after S1 is opened. Toggle flip-flop, that is the toggle flip-flop, but it is a SR flip-flop. Remain off when S1 is closed and continues to remain off after S1 is opened. That is the question in instrumentation branch. Now, once we are making this close, there will be the current through the LED. When LED will glow, there is no delay. That's why the resistance under illumination will reduce. It will become 0.5 kilo ohm. 500 ohm means 0.5 kilo ohm. Once it is reduced, what is the voltage at this point? The voltage at this point will become 1 divided by 1 plus 0.5 into 5. That is 5 divided by 1.5, and this is greater than what? 2 volt. 5 divided by 1.5 voltage division rule, to negative terminal voltage become greater than positive terminal voltage. That's why it is low. It will become 0. Once it is the low value, when it will become 0, output of comparator, it will give the negative trigger. Initially it was 5 volt. Once it will get the trigger, Q will become 1, Q bar will become 0. Once the Q will become 1, high, transistor will be on. When the transistor will be on, now the current will pass through what? Transistor. Once the current will pass through the transistor, LED will glow because it is forward bias. Now when we are opening the switch, it doesn't matter. Now the current will pass through the transistor. When the current will pass through the transistor, LED will glow. LED will glow means what is the resistor? 0.5 kilo ohm. 0.5 kilo ohm, the voltage at this point will remain at what? 5 by 1.5, that is greater than 2. It will remain at 0. If it is remain at 0, it will remain at 1. Transistor will remain on. That is the case. Once turn on the switch when S1 is closed and remain on after S1 is opened. S1 is opened. So here we are connecting the SR flip-flop, here we are connecting the LED, here we are connecting the transistor, here we are connecting the comparator, that is by using operational amplifier, right? Light dependent resistor. So this question is very, very important, no doubt. This is for instrumentation branch, but this is good question. Okay, so in this way we can find the value, and here we are using the S bar R bar latch where we are giving the negative trigger. S bar R bar latch. By we are making S bar R bar latch by what? NAND gate. NAND gate. So which type of S bar R bar latch? Hope so you enjoy the session. If you want the PDF of this session, to my dear friends, join my Telegram channel. Already I have shared the link with you. Okay, so this is a test series for you. I'm again sending you the link. Join my Telegram channel if you want the PDF. Okay, then that is Electronics by Sanjay Rathi. So this is GATE and ESE test series. Get unlimited access to full length mock test, subject test. Link in the description box. It is given. Right? Sir, please make a video only for electrical analog previous year question also. Okay. Okay. I will try to make. Now 60 plus GATE covering GATE and engineering services. Pura test है, 60 plus tests are available. Detailed mock analysis. I am now tomorrow I am going to take one session on that from 11:30 where I will discuss all the mock questions. Virtual scientific calculator are available there. 4,000 plus practice questions are available. All India open mock tests are available, and that is designed or curated by what? GATE experts. Okay. So these you are going to get the good questions and try to solve all these questions. So that is the test series for you, and this is the time for test series. You are on BYJU'S Exam Prep. Thank you for attending the session. Thank you very much. Like the session, subscribe our channel and share the link of this session. Thank you and good night.